Hi everyone, welcome to this lesson on classifying triangles. So we're going to look at a bunch of different triangles in this unit, and we need to know how to be able to classify them. So to give them their proper name, in other words, depending on their different properties. So if you look at these four triangles here, you can see that they're, in addition to being four different colors, they have some markings on them that indicate things like side lengths and angles. So just take a moment, pause the video, and try and think, try and think if you know what the names of these triangles are based on what you see in the diagrams. Okay, so let's start up. The first one, the red triangle, has three sides that are all the same length. That's what's meant by these little dashes here. The three sides all have one dash, and that indicates that those three sides all have the same length. So when we have a triangle with three sides that are all the same length, that's known as an equilateral triangle. Equilateral. Oh, that's a really long one. Okay, in the second triangle, the blue triangle, we have two sides with that little dash, indicating that only two of the sides are the same length. That triangle is known as isosceles. And I never seem to be able to spell this properly. Isosceles, I think that's right. The third triangle, the yellow triangle, has no dashes on the sides, so that means that all the sides are different. However, it does have this little square here, indicating that that angle in the corner is a special angle. Specifically, it's a 90-degree angle, and so in this case, we call this a right triangle. A right triangle. And the last triangle here has no markings on any of the sides, and no angles are special values. So in this case, we call that a scalene triangle. Okay, so those are the four kinds of triangles that we're going to talk about. Now, there are actually a couple of instances where we might combine a few of these. For example, you can have a right isosceles triangle. So for example, in the isosceles triangle, if this angle here were a right angle, then that would be an isosceles right angle. An isosceles right triangle, excuse me. Furthermore, in this right triangle, because none of the sides are the same, we could actually call that a right scalene triangle. Generally speaking, though, the scalene is kind of implied, and you would only ever classify a triangle as scalene if it's not one of the other three. Okay, so basically what we're going to be doing in this unit is we're going to be using some of the tools that we've developed from analytic geometry. We've developed the distance formula. We've developed the midpoint, and we know from grade 9 that slope equals rise over run, and that gives us a connection between parallel and perpendicular lines. We are not going to be using some of the traditional tools that maybe you've used in years past. We're not going to be using rulers or protractors, so we're not actually going to be measuring anything directly. We're only going to be using the tools of analytic geometry for our classifications. Before I go on to an example, I just want to have just take a moment and talk about how triangles are labeled. So generally speaking, you label the triangle with letters, and it doesn't, and you choose letters. Traditionally, we use A, B, and C. Although we don't have to use A, B, and C, and if I have more than one triangle, I might use letters like D, E, F, or X, Y, Z, or that sort of thing. But that being the case, I can label this triangle A, B, C. So in this case, this is triangle ABC, but also by labeling the triangle this way, I have not only labeled the vertices, I've also labeled the sides. So this side, for example, here is side AC. Okay? And also this side is AB. And the remaining side is BC. Or CB. It doesn't actually matter. Okay, so the letters here, A, B, and C, actually refer to the angles. And if I want to talk about the sides, I use AC, AB, and BC. Okay, so let's look at a problem. Suppose triangle ABC has the following features. What type of triangle is it? So in this case, I've done all the work for you. There's no need to use distance formula or slope or any of that sort of stuff. I've just put everything into a chart. And it's your job to classify it based on this information. So where to start? Well, you see that I have two sides, side AB and AC. Two of those sides have the same length. So because of that, I can say, and the third side is not that same length, so it's different length. And so because of that, I can say that AB equals AC. Sorry, I should say, since AB equals AC, triangle ABC is isosceles. Isosceles. Okay? So that's the first thing. And the second thing is if I look here at the slopes, I see that this slope is 2/3 and this slope is -3/2. Those two are perpendicular. Those two sides are perpendicular because the slopes are negative reciprocals. This one over here is a slope of 5, which doesn't really mean anything. It doesn't relate to the other ones in any special way. But these two sides, AB and AC, are perpendicular. So since side length AB is perpendicular to side length AC, angle A is 90 degrees. Okay? It has to be angle A because angle A is the only angle, the only angle which is common to both sides, right? This is AB and AC, so they have to basically share the angle A. So now we put it all together. I have an isosceles triangle with a 90-degree angle in it, so ABC, therefore, triangle ABC is a right isosceles. Okay, and that's it. So just using that information, I can write some statements here, here, and then make a logical deduction based on that evidence. All right, I'll see you in class. Have a good one.